Welcome back to another edition of Mathematics Time with Maxwell. Today we are going to look at a circle question. Quickly, let's go to the question. And this is the question. Show that if the line y is equal to mx plus c is a tangent to the circle y squared plus x squared is equal to r squared, then c squared is equal to r squared into bracket 1 plus m squared. B. Find the equations of the tangent from the point 4, 12 to the circle x squared plus y squared is equal to 16. So now let's take the equations. We have the tangent equation being y is equal to x plus c, which is a general straight line equation. We can rewrite this and we'll have y minus mx minus c is equal to 0. Now let's take the equation of the circle. In our question, it is x squared plus y squared is equal to r squared. Now let's compare that to the standard equation of a circle, which is x minus g all squared plus y minus f all squared is equal to r squared, where r is equal to radius and negative g comma negative f is equal to the center, is equal to the coordinate of the center. So in this equation of a circle in this form, it's clear that when you compare coefficients, our center is the origin 0, 0. Now, if you have a linear equation, or let's say a tangent to a circle with equation of the form ax plus by plus c is equal to 0, then the radius the distance of the radius can be given as r is equal to modulus ax1 plus by1 plus c all over root of a squared plus b squared. So when we compare this equation to ours, it's clear that our a is equal to negative m and our b is equal to 1 and our negative c is equal to positive c. And then our x1 comma y1 actually is the origin, which is 0, 0, 0, 0. So let's fit the values in quickly and let's see the results. We have r is equal to modulus, of course our a is negative m into 0 plus 1, 0 again, plus c all over negative m all squared, root of that squared plus 1 squared. Now this gives us modulus of c all over root of m squared plus 1. Now if we multiply both sides by root of m squared plus 1, no, let's square both sides. Now squaring both sides, squaring both sides, we obtain r squared is equal to c squared over m squared plus 1. Now note that if you have modulus of c and you square, your result is always c squared. So this is what we have. If we multiply both sides by m squared plus 1, we end up with c squared is equal to r squared into m squared plus 1. Now proven. Good. Now let's go to the second sub question, that is B. Now with a B, we have the equation of a circle, x squared plus y squared is equal to 16. Now when we compare this to, of course, the standard equation of the circle, y minus f or squared is equal to r squared. This implies r squared is equal to 16. So, therefore, our r is equal to root of 16, which is 4. And our center will be, again, when you look at this, you see that the center is 0, 0, the origin. So let me draw, and then according to the question, the tangent line starts from the point 4, 12 all the way to the circle and meets the circle at a certain point we don't know. So let's try and draw this so that we can have a clearer picture as to where we are heading. Now if this is my point 4, 12, and the line starts over there, cuts here, and then goes there and cuts there, that means we have two tangents emanating from the same point and touches the circle at two different points. So we have two tangents. We have to find the equation of the two tangents. Okay. Now, from the previous solution, we saw that c squared is equal to r squared to bracket m squared plus 1. So, given the point for this point 4, 12, and given our tangent line y is equal to mx plus c, when we set this point into this equation, we will get 12 is equal to 4x plus c, which means c is equal to 12 minus 4m. Now, from A, we know that c squared, but c squared is equal to r squared into bracket 1 m squared plus 1. So anywhere we see c, we are going to slot in this value, and we have 12 minus 4m all squared is equal to r squared, but our r squared is 16. You can see clearly here 16. So we just slot in r squared 16. We don't know m, that's what we are finding, m plus 1. Now let's expand these two equations. We have 144 minus 96m plus 16m squared. Now let's distribute 16 through the parentheses. We have 16m squared plus 16. Now when we have the same values both on the left and on the right hand side of the equation, and have the same operations in front of them, we can cancel them out. They nullify. This one nullifies. Then we are left with 144 minus 96m is equal to 16. When we rearrange this equation, we are going to have 96m is equal to 144 minus 16, or we are going to have 3m is equal to 4. Therefore, m is equal to 4 on 3. Now, using the straight line formula, y minus y1 is equal to m into bracket x minus x1, x minus x1, and then we also use the point 4, 12, and we know that the value of m also as being 4 on 3. We fit this value into this equation, and we will obtain y minus 12 is equal to 4 on 3 into bracket x minus 4. Now, readjusting or multiplying through by the denominator value, which is 3, we will have 3y minus 36 is equal to 4x minus 16, or we have 3y is equal to 4x minus 16 plus 36, or 3y is equal to 4x plus 20. This is the first, this is one of the tangents, one of the equation of the tangents. Now, clearly it can be seen that if this is the radius, which is actually 4, we can see clearly that our second tangent line is actually the value x is equal to 4, because you see the eastward stretch from the middle of the circle is 4, and when you look at this point, the eastward stretch is also 4. That means this point is lying directly on top of the point, the tangent point here, the point the tangent makes with the circle. So the radius from the center to this point is perpendicular to the point 4, 12. So our second tangential line is x is equal to 4. Thank you very much for joining us for this edition. See you next time in our next edition. Thank you. Bye.